Good morning folks and welcome back to 4am. My name's Rob and today we're going to move on to our generate modifiers. Now these are the exciting ones, these are the ones that you're most likely to use, these are the ones that's going to help you produce stuff. These are the ones that I've used the most and these are the ones that I know the most about. So our generate are these modifiers here. So you have array, bevel, boolean, build, decimate, edge split, mask, mirror, multi-resolution, vmesh, screw, skin, solidify, subdivision surface, also known as subsurf, triangulate, and wireframe. Okay, so they're the ones that you're going to use the most. And just to give you a quick recap of the generate group of modifiers are constructive tools that either change the general appearance of or automatically add new geometry to an object. So that's why you're going to use them, because you're wanting to change the shape or you're wanting to create something different with your original mesh or change it somehow. So it's going to initially generate something different than what your original mesh is. Now when I say different, it's not the same in all cases. As you'll see with this array modifier, it doesn't actually affect the original mesh. This is literally just a quick way of creating duplicates of your mesh. Okay, so as always, I'm going to go through with the array. As you can see, it's just created a second one there. Now it doesn't look like a second one, it just looks like it's extended that, but we'll leave that for now and I'll go through it. So as always, I'm just going to go through all these options, tell you what they're all available for, what they're all going to do, and then we'll have a little play around. Okay, so the array modifier creates an array of copies of the base object being the one that is selected. If you've got a few objects that are all parts of the same object, it will copy all of those as well, so be careful with that. You may have to separate some of the objects, with each copy being offset from the previous one in any of a number of possible ways. So offset means it's going to be separated by a certain amount of space. Vertices in adjacent copies can be merged if they are nearby, allowing smooth subsurf frameworks to be generated. This modifier can be useful when combined with tileable meshes for quickly developing large scenes. It is also useful for creating complex repetitive shapes. Multiple array modifiers may be active for an object at the same time. Example, to create complex three-dimensional constructs. Okay, so you can apply two of these in this way. If I put that to 0, now essentially this is the only one that's active now really, because this is all 0, it's not really copying anything. But it's just underneath this one. So if I do one on there, you can then see it goes to there. Do one on there, it then moves it up. So you can use multiple ones, which I'll show you a little later on, but that's just today. Obviously, whilst I'm just going through the script, just to show you a little bit of what everything does. Okay, so then we have, obviously you have your apply, you have your copy. Fit type, you have fit curve, fit length, fixed count. So fit type controls how the length of the array is determined. There are three choices activating respectively the display of the curve, length or count settings explained below. So when I say below, that's obviously my part. Fit curve. Now for this you do have to create a curve. So generate enough copies to fit within the length of the curve object specified in curve. So you would simply add a curve and then scale it back to your original object, select your curve, and now it keeps doing this, but that's apparently the amount that it can fit inside that curve. Actually, it uses the geometry of each individual face that it runs through to calculate how much it can fit in there. Now this is not necessarily the same length, because it does go across the other faces there, so I think it actually counts in those half faces to match how many squares it can actually fit inside there. Curve might not be one that you use very often, but you may do. Then we have fit length. So let me just get rid of that a second. Fit length generates enough copies to fit within the fixed length given by length. So you go into fit length, you then have length, and depending on how you've got it, so set it to metric, you then have meters, and we want this 4.5 meters long is 4.5 meters. So we do that as 1, 2, 3, 4, 5. It's pretty much about 6 squares, but you know, 1, 2, 3, 4, 4.5 meters plus your original square. So yeah, I guess that's how it works. But yeah, anyway, that is now 4.5 meters. That's your fit length. And then again, if you want it to 2 meters, you do it to 2. 10 meters, you do it to 10. You get the gist. Then we have fixed count. Now this is the one that you're probably going to use the most. This generates the number of copies specified in count. So I'm just going to offset this a little bit, just so you can see. 1, 2, count of 2. Now this offset will count for every single duplicate that you create. So if I do 3, it's offset by the exact amount. So this is useful maybe when, you know, if you're trying to separate a few things a distance apart and you've created a duplicate by Shift and D and you need that specific space in between, rather than trying to get it correct, use this modifier. So this can literally just go on forever, or you can just type in 5, or you can type in 4. You can do whatever you want to do. So that's your 3 options there. As I say, fixed count, and maybe if you're doing like a floor map or something like that, then maybe you might use fit length or something. But if you're doing like a floor map, then I'd suggest not doing the offset. Not doing the offset to put a gap in there, just do it as 1 so that it's right next to each other. Turn that back to 2. And yeah, leave that on 1. Okay, so jumped ahead a little bit there because yeah, curve, the curve object to use to fit the curve, which as I say you have to create one. Length is the length to use to fit length, and then count is the number of duplicates to use for fixed count. Sometimes this script can be a little backwards, so I have to jump backwards and forwards, but yeah. Okay, so both fit curve and fit length use the local coordinate system size of the base object, which means that scaling the base object in object mode will not change the number of copies generated in the array modifier. So if we do fit length, just so we can know what this is talking about really. We scale that, that's going to scale that. Okay. And then if you scale it in object mode, it's not going to change. Right, okay. So if you scale this here, because it's set over here as 10 meters, if you scale it down, it's still calculating that that gap is 10 meters, no matter which way you scale it. So if you do it huge, do it small, negative, positive, it does not matter. The geometry of that will, the length of that, should I say, will still stay as 10 meters. Now if you go into edit mode and we scale it down, it will add more and more squares, because the geometry inside edit mode and inside object mode are completely different. So be careful of that, of which way you're changing it, inside object or inside edit. If you change it in edit, it will add more geometry to it. It'll add more squares to it, or more objects, or whatever you've got. If you change it in object mode, it won't change anything at all except for the pure scale of the size, and that's it. The length will still stay the same. So then fit length uses the local coordinate system length of the curve, which means that scaling the curve in object mode will not change the number of copies generated in the array modifier. Okay, so that we're using fit length. I think that's actually meant to say fit curve, to be honest, because if I now add in, oops, if I now add in a curve, scale that out, it doesn't change it at all. Go into edit mode, scale it. No. Okay, so what you'd have to do is, I'm not great with curves. It's not something that I've used. It will be a different tutorial to go through that. But I should imagine that if this is around a curve, then it'll treat it the exact same as what I've just shown you then. So if you adjust the curve, it'll just make it bigger inside object mode. If you change it inside edit mode, then it will do the exact same as this, and it will start creating or deleting squares. So it's exactly the same as that one. It's just used with the curve object. Applying the scale with Control A can be useful for each one. So Control A is this little guy here. And I mean, it doesn't seem to do much here, but if you use this with your curve, so maybe if I do Control, let's see, if I scale this right down to here, go out of object mode, and then do Control and A, set to scale. No, that doesn't change anything for me with that. Yeah, so that's got to be used with a curve then. Okay, so then we have our constant offset and relative offset, both of which can be applied at the exact same time. So, as I showed you, one is it's one square away, but obviously it still looks connected there. You have to move above one to actually get a space in between. However, with the y and the z, just 0.1 creates that little bit of offset. Now, because we've set the scene up as metric, our offset is now in metric, which is your centimeters and meters. If you want to do, and obviously in different parts of the world, imperial, you can then have inches and feet. But again, that's you know, all these options here, I'm going to go through all these on a different tutorial anyway, and this is literally just to show you the modifier really. But when you're showing the modifier, sometimes you have to include other stuff. So apologise that I do go on a little bit. I just want to make sure that I'm getting the best out of this tutorial, and everybody else that's watching it they're getting the best out of this as well. Okay, so you then have, we'll go back to our modifier, constant and relative. Now as you see over here, x, y, z, these are still x, y, z. Don't like it when it says a minus when it doesn't need to be a minus, but not that it affects it. So a constant x, y, and z. Adds a constant translation component to the duplicate object's offset. X, y, and z constant components can be specified. Then your relative offset adds a translation equal to the object's bounding box size along each axis multiplied by a scaling factor to the offset. X, y, and z scaling factors can be specified. So if we turn this off, let's go to back to fixed count as normal. Okay. So we're just going to work with 2 for now. So if I do relative offset and turn that off, it's literally, there's a square hide underneath there. So if I now do constant offset, it's now going to move that square out a little bit. You may not be able to see because it's only by pure centimeters, but as you can see just there, there's now 2 squares there. Okay, so if I turn that off and put on relative, it now uses the exact size of that box, the original box, to offset by the whole amount. So if you want to move stuff, the way I look at it, if you want to move stuff by like literally by centimeters, use the constant offset. It's more precise. If you are just wanting literally to duplicate it of a relative distance apart, then use this one. But play around with it before you do apply. Apply should be the last thing you ever do with a modifier, because it makes it permanent. Although you can Control and Z and, you know, change that. Which reminds me, actually, I'll just put my my screencast keys on just so you can see everything that I'm doing. Yeah, although you can do Control and Z and unapply the array modifier, if you've took so many steps, then you won't be able to. And you can change the amount of steps for your Control and Z. That's going to be, again, included in a different tutorial. I've got mine set to 100 just to make sure if I do any mistakes, I can just literally undo everything for quite some time, to be honest. But yeah, that's your constant and your relative offset. As you see, you can use any of them, or you can use them both together. Okay, so we have object offset, which is this one just here. So with our object offset, you have to have something in there. Now you can use camera, which put our guy up here. You can use the lamp, which put our guy over there, because it's offset by that space. Now, one of the useful things might be to create an empty. Okay, so we create our empty, we stick them up there. I don't like using empties. It's not something I have a lot of knowledge about, because they're used in so many different ways. But use your empty there, and then wherever you change this one, your other square is going to follow. You rotate, it's going to rotate with you. You scale it, it's going to scale it with you. Anything you do to this empty or to whatever object that you have picked, this will do whatever that does. So again, if we choose the camera, we click on the camera, we rotate the camera, it rotates your box. No matter what object it is, it will change when you change that object. And hopefully you get that, and just to see if it will do it, Shift and D. No, that only copies that part. I did think that was going to happen, but I just thought I'd try that just for my own curiosity. So just that Shift and C, just to put the cursor straight back into the middle there, so I know that where it is. Okay, so object offset adds a transformation taken from an object relative to the current object to the offset. It is good practice to use an empty object centered or near the initial object. Example, by rotating this empty or circle or helix of objects can be created. So, just to show you what they mean, if I was to put this down here, go into first view, why am I working in perspective? I hate perspective mode. Okay, so if we do put that back to 1, because of this empty is the space of 1 square, that's now essentially that's now 2 squares, because it's offset by this object, which is 1 square, offsets this square by 1 square to this square. Hopefully that makes sense. I did say square a lot of times then. And once again, you know, rotate, scale, anything you do to this, it affects this one. But if you notice, does not affect your first one, because this is your base object, this is your duplicated object. So if we now do 3, 4, notice the space in between is the same amount as this guy here. And if we rotate this, it will rotate all of them. Now doing this, as you can see, you can create some Some fantastic stuff, to be honest. So I suppose that's how you could create any helixes or anything like that, is by doing that. I wouldn't create a helix in this really. I'd probably do that using the screw modifier, or both of them in conjunction with each other. You never know. But yeah, by using this object, it changes the rest of your copies. Oh, that went a little crazy, didn't it? Right, okay, yeah, because it's got to keep the constants offset. That's pretty cool. See, you learn something new every day. That's fun. So then we have merge. Now, if you turn off relative, use constants and use, let's say 10 centimeters. Okay. Now let's get rid of the object offset a second. No, I'm gonna have to use that. Okay, sorry about that. Okay, so this is offset a little bit, obviously, because my empty is offset. That's the only reason that's doing that. So if I was to go into top view, grab that along the Y, and just move it down here. Okay, there we go. So you can see that they're all straight when I'm working with this now. Okay, so that's now 10 centimeters in between each gap. Okay. Now with merge, if enabled, vertices in each copy will be merged with vertices in the next copy that are within the given distance. So this is the distance down here. So if I now change that, there we go, 11 centimeters, you have to go to one extra. It will then merge it. You have to go to one extra because it's within that. Within 10 will be 9. Within 11 is 10. It then just merges them all together. Okay. Then we have first, last. If enabled, and merge is enabled, so you have to enable merge and first, last. Vertices in the first copy will be merged with vertices in the last copy. This is useful for circular objects. Okay, so if we do this, let's have a look. Let's go 60 centimeters. It's merged everything into one little thing. 50 centimeters, 20. Ah, it's meters, that's why. 50 centimeters. Okay, so now that's merged everything because the space from here to here, they're only offset by 10 centimeter. So if we just start going down a little bit further, it should release one square at a time, really. There we go. So basically this is going to work on this one gap here. So this gap is 10 centimeters, this gap's 10 centimeters, this gap's 10 centimeters. All of these squares have the same properties. So if it's merging distance of 10 centimeters from here to here, then this is going to merge with anything within 10 centimeters of it, and this will merge within 10 centimeters of it. So 11 centimeters merges everything together. And as I say, merge and first and last, they both have to be done together. Now, let's say we don't use that. It's now no longer 10 centimeters. This should probably be about 10 meters. So that's merged everything in between the first and the last together. So if I now start dropping this, 9, 8, There we go. Now it's only merged in the first 8 meters. Don't forget this is 10 meters, this whole thing, because we set it as 10 meters. So if we go to 6, it'll then release 1, 4, merges them back, because it's 4 meters from each square. 2 meters is back to normal, really. So you may need to play around with it a little bit, but it can become confusing. It's not really something that you're going to use that much, to be honest. Okay. So then we have our distance, which I've just been playing around with. Then controls the merge distance from merge. Start cap, end cap. This allows either endpoints of the array to have a different mesh subsisted. For the start, as if it was in position -1, i.e. 1 array step before the first regular array copy, and for the end, as if it was in position n+1, which is 1 array step after the last regular array copy. When merge is activated, so again, merge has to be activated there, and the cap vertices are within the distance threshold, they will be merged. Okay, so with these, the start and the end caps, when merge is activated and the cap vertices are within the distance threshold, they will be merged. The start and end cap objects currently do not support the first last option. Okay, so can we select? It won't let me use an empty. Fail to set value. Maybe if we apply this, okay, so 001, cube in the middle, 002 at the end. If I now add on an array at 1, okay, so start cap 002, end cap cube. Okay, so that's now picked cube 002, which is this guy here, cube, which are these two, and merged everything in between, making these extra two. Well, I see that that's disappeared there then because it's not applied. But if we were to do it like that way, on a count of 2, it goes from here across, count of 3, etc. You can see the pattern. And then you can actually offset those extra ones that they've made there, because it's actually copied from cube 2 back to cube. So 1, 2, 3, it's copied, moved across by 3, then creates 6. It's a little awkward that, but again, it's going to be something that you're going to mess around with, and that's why I've set my Control Z to 100 so that I can go back to my original modifier. It should took me 58 times to get back there, but I did it. Okay, so what I'm going to do is I'm just going to open up one of my. This is one of my things that I've been working on here. So let's say that this is basically, it's meant to be a grave, this, so yeah, don't laugh. Oops, what I'll do is Control C. Start my screen keys back on a second. Okay, so Control and C, put your cursor back straight into the middle there. Shift A, add a mesh, scale it by 10. Okay, so let's just say this is a ground and I want to create a graveyard, basically, okay? Let's do an array. Move this across here, grab it along the Y, And the reason it's going back that way is because I was looking at it from the opposite direction. So there you go, there's a quick way of making them. And then if we apply that and we add on our second array and we do that to 0, y to 1, take it in the minus, so let's say -3, we then create a load of headstones. So as I say, you know, this is a very easy way to create a large amount of stuff. I've just created, you know, a graveyard with 2, 4, 6, 12, 24, 48, 54 gravestones in the space of about 10 seconds. It's so easy to do. And it's fantastic. So that's why you would have multiples added on. So again, you know, before I applied that other one, I could add in an extra array there. You know, I didn't have to apply that one at all. Set that to 0. Set that to 4. On the Y, why is it not? Oh, okay, maybe I've run into a little, there's a problem there. Ah, because I've done 1, that's why. So, set that to 4. Ah, it's -4. -5, that'll do. And then, there we go. Full graveyard of headstones. So it's just it's that simple to use, and then you know you can, if you wanted to not make it so, you know, inline or anything like that, mess around with those a little bit. In something like this, you probably wouldn't use an object offset because, you know, it's crazy. But yeah, that's it. And next video will be the bevel modifier. Thank you very much.